Good morning. It's always interesting, the morning after the party, it's like a little bit more quiet in the room and people are just sitting there like, oh, scroll on their phones. So I hope you enjoyed that party. If you enjoyed it a bit too much, try to find some energy to get it through this talk because it's going to be high pace. I have a whole bunch of takeaways. I honestly haven't counted them because, well, the length of the talk always varies, so the number of takeaways does as well. But we're going to talk about API security. We're going to talk about a whole bunch of things that go wrong, and I'm going to talk about a whole bunch of ways to fix those problems of going wrong. I'm going to show you how they come into existence and what we can do to actually counter them. And what I would really like to happen at the end of this talk, I'm going to mention that again, is that you'll take the takeaways from this slide, you'll recognize from this presentation, you'll recognize them by the slide format, and really take them to heart, take them with you to your company, and start applying those principles on your APIs sooner rather than later. All right. Let's dive right in with a study on API security from last year, from 30 healthcare apps in the UK. And the study found that healthcare apps, kind of sensitive data by design, I mean, they should have security kind of on a high level, and it shows that that's really, really not the case. So of these 30 popular apps, 77% contained hard-coded API keys. And that means if you put a secret in an app and you deploy it on a phone, somebody's going to take that binary file, run some tools on it, and find those secrets, allowing them to abuse that. And 7% even contained hard-coded usernames and passwords, which goes as far as full database access usernames and passwords, which is kind of like an oopsie, if you want to call it that. That's absolutely horrible. And that's something we talk about. The first thing you learn when you learn about mobile security and client-side security is like never, ever, ever put secrets on the client. And it's actually worse because the study also looked at APIs behind these apps, and they found that of the APIs they looked at, they haven't tested all APIs, but of the APIs they tested, every single one of them had authorization problems. Every single one of them. And that brings me to the first takeaway of this presentation. Yes, it goes that fast. First takeaway, the cowboy years are over. As in, we can't keep doing this. This is absolutely unsustainable. If we keep handling security like an afterthought, like, oh yeah, we'll look at security when we have some time and money in the future, that's not going to work. It simply doesn't work. You have to look at security from the start. You have to build up your security mechanisms, your culture, your skill set basically, and start ensuring security from day one. And that's something that's actually changing, and that's a good thing, because my customers are usually, or used to be, very big companies with like established security programs and money to throw around for consultants and so on and so on. And these days, I often work with startups. Startups that don't even have a product out. They just secured some funding and they're like, okay, now we can do security before we even have our first customer because we know that we won't be able to do it afterwards. And that's the right attitude, and that's definitely a good starting point. All right. That's just to get you warmed up. I'm Philippe De Ryck from Belgium, and I run my own company called Pragmatic Web Security. And if you were in my talk yesterday, you've heard this pitch, so you can go rest for 1 minute and recover from the party. Otherwise, you might be interested to learn that I help other people build more secure software. So I provide knowledge on security through training, consulting, online courses, and so on. And I also organize a course in Belgium called SecOpDev, which is 1 week about application security taught by people from all over the world. It's like a conference, but longer and more in-depth, and absolutely awesome. So if you are ever interested in visiting Belgium, we have good beers, by the way, if you're into that, then you might want to convince your boss to send you to SecOpDev. That would be great. All right, back at API security. API security is a big thing, right? Well, everybody's doing APIs, so kind of logically that API security becomes more important. We even have a dedicated OWASP top 10 for API security. And if you look at the OWASP top 10, you might get a little bit depressed, actually, because a lot of these issues are about authorization and authentication. Almost 40%, and depends on how you count, if you include authentication as well, 50% of the top 10 are about authorization and authentication issues. That's massive. I also see that there's a bunch of overlap between the OWASP API security top 10 and the traditional web application security top 10. Like there's some overlap, injection is still there. A problem that we've been dealing with for 25 years is still unsolved in APIs, which is again unsurprising because APIs are just a different way of building an application. Based on this top 10, you can kind of imagine I'm going to talk about authentication and authorization a bit today, but before we do that, I want to talk about number 4, lack of resources and rate limiting. And I want to talk about this because it's kind of a weird issue that that is often under-recognized. People are like, oh yeah, sure, denial of service, that's important. We need to protect against denial of service attacks. And yes, that's true. And if you think about denial of service, like filling up the network connection so you become unreachable, or abusing CPU or memory of your application so it becomes unavailable, sure, that's a problem. If it's not available, you likely lose money, have unhappy customers, and so on and so on. But to me, it's not the biggest security issue that you can have in your applications. And if you start thinking about this issue, there's actually a whole bunch more that goes on there that's often just brushed over or forgotten or not even considered. For example, what about abusing application features? Wouldn't it be the first time Facebook had this problem in a bunch of their APIs where you could reset your password? And if you reset the password, they send you a 6-digit code over a text message or an email, and you have to enter that 6-digit code, and then you can choose a new password. And they forgot to implement rate limiting on that endpoint. Well, actually, they didn't forget. They had rate limiting on the endpoint. 10, 12 attempts, and you were out. Done. But they also had a beta API available publicly without that mechanism. So somebody figured it out, like, hey, that's the same endpoint, allows me to recover my account on the beta API, and they don't have rate limiting. So it doesn't take too long to guess a 6-digit recovery code with brute force. Lack of rate limiting, just like that. Abusing legitimate application features. Exceeding usage restrictions. We all know these plans where you purchase the basic plan and you get like 10 operations per minute or whatever you're doing. Well, those things need to be enforced. And many APIs, well, actually this is something they actually get right because that's kind of their business model. So they do enforce usage restrictions quite often in the right way, but that's also the same issue, often not considered. And then finally, we have large-scale exploitation. What happens if I abuse another vulnerability, an authorization problem, allowing me to access all the data in your application, all the documents? Why do we hear about data breaches where somebody downloaded like 100 million documents from an API and nobody even noticed that something was wrong? Well, if you would have had some rate limiting in place, some detection mechanisms, some limits, sensible limits, maybe the attack would have been cut off at 1 million, 100,000, 1,000, whatever you're doing. So all of these things fall under that same category. So it's more than just denial of service. That's the takeaway here. It's a lot more than just preventing somebody from taking down your system, which is the only thing we often look at. It's much more about enforcing sensible limits and building this logical way of approaching these problems. So that's the issue. How do you do that? Well, I can go into a lot of depth, which I'm not going to do here, so I'm going to give you an overview of different strategies you can follow. And I'll give you a teaser for the takeaway after this section. The takeaway is going to be combine these strategies into something that makes sense for you. There's no one-size-fits-all solution. It's always going to be like, do this in combination with this, and together you may have a robust defense against high-volume or large-scale attacks. First thing is the common one. That's what everybody thinks about, like, yeah, infrastructure limits and computation limits. Like, you can put restrictions on your Docker containers and somebody can only consume this much memory instead of bringing down the whole server. Yes, those things are absolutely useful. Use them as a defense against hoarding resources, basically. Something much more trivial is application-level input validation. Very often, applications have features where you can specify an amount that you expect as a result. So a pagination feature, like, oh yeah, page 7, 10 items. Well, if somebody asks for page 7 with 1 million items, some systems are like, okay, sure, if that's what you want, bam, and they take themselves out just by trying to fetch that information from the database. Having input validation there, like a value between 10 and 100 is acceptable and rejecting everything else, that's a good first step. It's trivial and it's not fun and sexy to build things like that, but it's something that's really, really important to apply in practice. Offloading, that's the best one, because it takes the responsibility away from you. If you offload something, you can basically be like, now that's your problem, you deal with it. That's what we do when you use OpenID Connect. You offload, or SAML for that matter. No, when you use OpenID Connect, you offload authentication to an identity provider, which can be a service you pay, and then you tell them, like an Auth0, like, that's your problem. You deal with user authentication and password recovery and all of that stuff. I don't have to worry about that anymore. And it also goes for untrustworthy features, like authentication, very sensitive, but untrustworthy things like image processing. You get an image and you have to make a thumbnail out of it. Well, if something goes wrong, it's going to be that thing that goes wrong. There's all kinds of ways that can go wrong. Offload that to a separate service. Something you can build yourself and deploy yourself, sure, but compartmentalize it, isolate it. In case something does go wrong, it's only that small component that has a problem. It doesn't affect the rest of your system, your APIs, and your data. And then finally, application-specific rate limiting is very useful as well. Those are things relevant to your application. Have like a global catch-all, like we only allow this many requests per second per user, something like that. Or in the GraphQL world, we have limiting query depth of a GraphQL query, or even calculating the cost of a query. Look at GitHub, that's a very good example. GitHub has a whole documentation page saying like, if you send us a GraphQL query, this is how we calculate the cost, and you get this many cost factors, I don't know what they call it, per month or per hour or whatever. And after that, we cut you off. And that gives you a way to estimate like, okay, the query I'm gonna make is gonna be this expensive and I have this much budget left, so yes, I can do that. Or maybe I shouldn't do that. Those things really matter. And the true defense is a combination of all of these things together. Like compartmentalizing, putting things separate, making someone else responsible for that. Having some sensible limits, having solid input sanitization, input validation, strong limits on the application. All of that is going to be your defense against OWASP API Security Top 10 number 4, which is lack of resources and rate limiting. All right. What about the client? Let's talk about Bumble. Bumble is a dating app, and like many apps, they have this freemium model, right? They entice you into signing up for their service, and then they impose some limits, and they try to trick you or convince you, let's call it convince you, to buy the paid version of the application. And their goal is to help you find a match, which is kind of against their business model, so I'm not sure how that works, but their goal is essentially to have you find a match in life. And they had some limits on the free version, and it turns out that those limits were largely enforced on the client. So somebody looked at the client app and said like, oh, I can only swipe 10 times per day or something, unless I pay them money to do more. But the API never enforced these things. So if you analyze the API calls from the client, you can intercept them, you can monitor them, and send them out again. You could keep doing whatever you're doing. Same thing with having access to locked features. If an account was locked for some reason, the front end said like, oh, the client, you can't access the application anymore. But the API was like, I don't care. Just send me a request, I'll do it anyway. Sure, it takes some skill to be able to do that, but that way you could get free access to Bumble's premium features, which is very illegal, by the way, so you shouldn't do that. Just as an example. And this happens everywhere. So this is an example from Twitter. A couple of years ago, Twitter had this brain fart called Fleets, which was around for like a few months, and then they said like, yeah, this was not a very good idea, so they killed it again. But it was around long enough for somebody to look into that, and they enforced transactional integrity on the client. Like, they fetched a temporary fleet, and then they sent a read notification to the API like, okay, the user has read this. Which of course means that an attacker could stop that read notification. They could get all the information without the other person or Twitter knowing that information was consumed, which is, again, not how things are supposed to work. They also had things disappear after a while. That's the whole point of temporary data. It disappears, but the client just didn't show it anymore. The API still returned the data if you knew how to get it, which is, again, not how things are supposed to go. What I'm aiming at here is that the client is irrelevant for security. And this is a very, very, very common problem in API security, that people often consider the client and the API together. That's what your quality assurance team is going to look at. They're going to look at the client like, can I swipe more than 10 times? Oh no, it's blocked. Good, check. What else do we need to enforce? Oh, this, let's test it out. Oh, it works, cool. But what people often forget is that an attacker can bypass the client because they control the device, they control the network traffic, they can easily intercept that. There's plenty of tools for that. Inspect the API requests and send whatever they want. Restrictions from the client are useless when it comes to security. Same thing for hidden API endpoints. Oh, it's hidden, the client doesn't use it, nobody knows it except our admin client. Like, yeah, awesome, security. Not really, because attackers literally have dictionary lists of common API endpoints. And they just load a list in a tool like Burp, and they hammer your API, and they get a 404, 404, 404, 500. Like, ooh, interesting. And they have found your hidden API endpoint. So you can't hide these things in practice. Somebody will find it, and somebody will abuse it. And that's your attack surface. Every endpoint you expose is your attack surface. That's what you have to look at when you secure your API. When I talk about this, on a moment not after the party, people are often more responsive, like, hey, hold on. Are client controls really useless? Like, isn't that good user experience to enforce things on the client? It's like, yes, it is. Good. This was a very short-sighted takeaway. It's not complete yet. I have to nuance this a little bit. So yes, client controls are useless for a user experience. If the user is not supposed to access a feature, don't offer them access in the UI. That's a common principle. That's good. And it goes even further. I would say mimic all the checks you do in your API, mimic them in the client. Input validation on fields like, hey, this field can only contain these values, enforce that in the client and in the API. Same thing with authorization. And that gives you a very useful feature. Because if you enforce that in the client, on legitimate behavior, how often should those controls fail on the API side for legitimate use cases?
Never.
Never. Thank you. Did you go to the party, sir?
I tried to leave a bit early.
Yeah, that explains. That explains. Awesome. Seriously, your API controls shouldn't fail if the client enforces the same controls. And if they fail, well, in my case, I probably have messed up the client. That's how things go. But in other cases, it's typically someone messing with your API. If you all of a sudden get invalid data there's no way that can pass through the client, and somebody's messing with a network request and seeing what your API does when they send you malformed data, malicious data. And that allows you to raise alerts. Now you can monitor the behavior, like, what the hell is this user doing? Like, oh, they're trying this. Haha, that doesn't work. They're trying that. Oh crap, they're sending this. We haven't thought about that. And now you can follow up on that and fix it. Or you can block the user. You can divert them to a honeypot, whatever works for you. So the takeaway isn't that the client is useless for security, but the client is irrelevant to enforce security. You can't enforce restrictions on the client alone, but if you do it at both places, then you get high confidence alerts that somebody is sending malicious data to your API. And that information is very useful for your security team to follow up on potential attacks. All right, back to the dating scene. Grindr, just like so many applications, has user accounts, email address, password, and people forget their passwords. That's how that goes. There's a talk about passwords later today, I think, so you might want to go there to learn how to make passwords a bit more manageable. At this point, we're not there yet, so what happens when you forgot your password? You enter an email address like philippe@pragmaticwebsecurity.com, you hit the button reset password, and you get an email with a secret token in the URL, and you click it and you choose a new password. That's how these things work, right? And that's exactly how Grindr worked. And the response, so that the front end, you enter an email address, sends a request, and gets a response from the API, and the response contains JSON data. And part of that data was the email address, so the front end can show you, we sent an email to philippe@pragmaticwebsecurity.com. Awesome. And that's all what the front end did, but the API response contained a second field, password reset token. That secret token that's only supposed to be in that email because it allows you to choose a new password was returned as JSON data in the response. And you don't see it. The quality assurance team, the testing team was like, yeah, this works, awesome. Until you look at the response data, open up a network tool and look at the actual JSON, and it's like, ooh, crap, that's not good. Because now you can go there, enter my email address, look at the JSON response, get my token, fill that out in the URL, and choose a new password, and do God knows what with my account. Don't tell my wife about that. All right. This is called sensitive data exposure, and it's really common because it's an absolutely invisible vulnerability unless you look at the network traffic. Here's the API security swag shop, which is very fictional, but whatever. There's a list of online users, which is probably not very GDPR compliant, but I'm going to leave that in the middle. And that list of users comes from an API response with JSON data, and the front end just picks whatever it needs and ignores all the rest. That's how these things work. And you can see that there's a bunch of shipping addresses there that probably shouldn't be there and that you might want to hide in your API responses. That's sensitive data exposure. OWASP API security top 10 number. Anybody? Nobody paying attention? No? No photographic memory? Number 3. It's that common, number 3. It's like authorization issues, authentication issues, like, oh crap, sensitive data exposure. It's everywhere. It's really everywhere. And here's how that happens. It happens because we are spoiled as developers. Seriously, because frameworks do everything for us. This is an example from Spring, like a really simple example. On top, we get a list of users. We fetch that list from God knows where in the system, and we return a list of users by calling on line 4 a new response entity, just like that. And you throw a bunch of Java objects in there, and Spring is like, oh, okay then. I'm going to make that into JSON for you, because nobody wants to write JSON by hand. If you've ever done that, you never want to do that ever again. especially if you have to start escaping double quotes, and it's like an absolute freaking nightmare. So middleware does that for us. Jackson in the Spring Java case. And .NET has the same, and Python has the same, and Ruby has the same, and they all do that because nobody ever wants to do that by hand ever again. And what happens is if you have a data class like the user, it contains, that's your model, that's what you use in your application, it contains all of these fields, and the JSON translator here will be like, ooh, fields, JSON, bam, bam, and out it goes, just like that. Code example on top, vulnerable to sensitive data exposure. It's that simple. Really common. So how do we fix it? Well, I have two solutions. One crappy one, and one annoying but better one. The crappy solution is by marking things as JSON ignore. That's always the easy solution, right? Oh, this field should not be exposed. Let's just slap an annotation on there, and the parser or the JSON translator will ignore that. Awesome. Good. The problem is you have to go through all of your data classes and mark every field you do not want to expose as JSON ignore. And if you forget one, you have a problem. OWASP top 10 number 3, sensitive data exposure, check. Well, that's the bad checklist, not the good checklist. So this works, but I don't like it. I don't like having to go through all of these things and remember that, and if you forget one, it becomes a problem. So the better solution is using this very old pattern called DTOs, data transfer objects, where we basically translate that user object, that internal concept, into something that has better semantics, like the public user info class. And if you complain about the verbosity of DTOs, well, you're doing Java, so you have no right to complain at all. This is just inherent nature to Java. But seriously, this has proper semantics. If you now look at the code, it says like, okay, what do we return? Oh, public user info. Awesome, what's public user info? ID and name. Very easy, very clear to see, and very hard to make a mistake. Yes, you can still add a sensitive address field to that public user info class, but it's going to be much more difficult to make that mistake by accident. Probably don't write it right after the party. Wait until tomorrow to update something like that. But seriously, if you make that mistake, it's going to be much more obvious than before. This is sensitive data exposure. And this automatic marshalling between JSON and other formats like Java objects, well, Java objects and JSON, results in a very interesting question. If we can trick an API, or if an API automatically exposes data by accident, what if we can make it accept data by accident? Wouldn't that be awesome? OWASP API security top 10 number 6, mass assignment. Mass assignment is the same problem in the other way around. Now we submit more JSON than the application actually expects and override fields in internal user objects. Here's how that works. Another crappy Spring security or Spring boot code example. On top, on line 2, we accept a request to update a user's data, and we accept user information. And we use that user information to update the user object in the system, which will result in updating the database, and so on and so on. And here's our user class. So we have an ID, a name, and a role in the system, like employee or admin or whatever. And here's the JSON. Well, that's that part, that's the red part. That's how we update the database. And here's the JSON to update my name to Dr. Phil. Easy, straightforward. You test this out, you enter the field in the app, you submit it, and it works, and everybody's happy. Awesome. Until the attacker comes around, and the attacker is like, what if I provide data like this? I provide you a name and a role, and that role gets picked up by, well, it gets translated from JSON into a user object, gets sent to the database layer, it updates all the fields, and bam, now I became an admin. Seems simple on a slide. It's like, oh yeah, of course. Happens in real-world systems. Results in account takeover. All kinds of really nasty vulnerabilities just because of mass assignment. Awesome, right? Thank you, JSON translators. I mean, how do we fix it? Well, this is kind of history repeating. We can use annotations to tell that JSON parser, like, yeah, this field should not be set from JSON, it's read-only. So you can expose it, but not accept it. Again, same problems here. You have to do this for every field, and I don't really like it. As in, it's too hard to make a mistake here. Forgetting one annotation, and you have a vulnerability. So why don't we use, again, a DTO class like this one, where we have update user info, and we only provide a name field. There's no way to smuggle additional JSON into this approach, and it kind of solves the problem by design. Yes, it takes a little bit more effort, but it's really, really worth it. And the takeaway here is kind of more general. It's test your APIs in their natural habitat. Because these issues often only become apparent if you start testing them in real-world systems. Because this might not always occur in development systems. It may not occur if you're not using the real API to test certain things, if you have a bunch of limited tests. So test them in a running condition. Test them as you would deploy them. And make sure you can find these vulnerabilities in practice. All right. Great way to follow up that takeaway, like test your APIs, and then is testing really good? Well, maybe the answer is yes for once. It isn't. It's kind of a giveaway when in trainings as well. When I ask something, people are like, yeah, it's not going to be yes, so probably no. And of course, then the question is why? Why not? In this case, it's unsustainable. You can't keep testing all API endpoints. Yes, you can do that a couple of times and you can write some tests, but this is not something that's going to work well reliably towards the future. This doesn't scale very well. So what can we do there? Well, there's this cool thing called Open API Specification, or Swagger, the old version. And it basically allows you to define the exact behavior you expect from your APIs, like a full contract. Like, hey, this endpoint will return application/JSON content types, and the schema of that looks like it's an array of items, and those array contains objects, and objects have an ID and a name, no address field. Awesome. Well, not really, it's YAML, so it's a pain in the ass to write. It's like space, enter. Okay. You also have the JSON version, which isn't better, by the way, so it's absolutely horrible. But there's tool support. Tools allow you to easily specify this. There's ways to add this to your code, so you don't have to have a separate specification file. You can just add it as comments in the code and generate documentation straight from this. That's awesome. You can generate docs from this. Like literally generate docs. Boom. Here's a full HTML website with API documentation. Cool. You can use this as a communication tool between teams. Ever had the discussion between frontends and APIs like, yeah, this returns something like this, and then it turns out it's something completely different, and everything breaks when you integrate them? Well, not with an API contract. You have tools that can use this as input and provide very useful features for testing, but also for security. For example, there's tools to find authorization vulnerabilities, give it a contract, and they will start hammering your API with requests that respect the contract but do something slightly different to see how it responds. And there's another tool from Microsoft as well. And more advanced tools, there's API firewalls that can take a contract as input and inspect requests as they see them go by and responses go back. And it can be like mass assignment, a request with additional JSON like, hey, the contract doesn't allow this. It either blocks the request or removes the data or whatever. And the same thing for responses, sensitive data exposure, like, oh crap, we have 5 additional fields being exposed and the contract says only 3. Like, no, let's not do that. Let's strip them or block the response or whatever we want to do as a response. That API contract enables security, so you have to start using it. Who here is using it? Who's using OpenAPI? About half of the room. When I'm back in September, I'm going to be at NDC Oslo, and you're here as well. I expect the whole room to be like, oh yeah, we're using it. And give your honest feedback. And we hate it. That's perfectly valid. I mean, that's absolutely fine. But seriously, this is the future. Security tools are consuming this, and it's going to get used more often everywhere. It's really, really powerful. It's just a little bit of effort to write it and keep it up to date, but it's really worth it in the end. All right. That brings us to T-Mobile. Well, I've been using this slide for a long time. It's from 2017, this article. Since then, they have had a couple of more breaches, but I'm not going to talk about those. Here, what happened here? T-Mobile allows you to fetch your account information. Like so many applications, like, hey, I want to see my account info. You send a request, and the identifier for your account is your phone number. Because that's kind of a unique identifier, so that kind of works out well. No need to generate a new ID. We'll just use the phone number, easy. So I send a request to the API, and with my phone number, and I get my account information. Awesome. And I send a request with your phone number, and I get your account information. Not awesome. Not good. That's what happened here. This is a problem that has been around. I don't know the exact date. I haven't looked it up for at least 2 decades, if not longer. It used to be called insecure direct object references, because that a phone number is a direct object reference, which is fine. There's nothing wrong with that. But the fact that it doesn't enforce authorization on that call, that's the problem. It should have checked when I asked for your account information, that was actually you instead of me. And T-Mobile didn't do that. In APIs, we don't call that insecure direct object references anymore. That wasn't sexy enough, so we call it BOLA, broken object level authorization, which is the same issue, just with a different name. And this issue, OWASP API Security Top 10 number? 1, thank you, awesome. People are waking up, so 9:30, first coffee is starting to hit, that's good. So number 1, this happens everywhere. Remember that study from these apps in the UK, the healthcare apps? 100% of APIs had this exact vulnerability. And here's some more examples. India patient portal, millions of patients, health information, whoops, that's a mistake. On Twitter, we could abuse a bug like this to match phone numbers to Twitter accounts, which is kind of sensitive. And then on Facebook, somebody figured out how to use this vulnerability to change the name of a Facebook page and then register a new page with the same name so they could hijack that URL to the page. 15,000 USD as a bug bounty, just to show you that this is not an insignificant, oh yeah, thank you for reporting vulnerability. This is like an, oh crap, let's pay the guy some money for having reported that issue. Happens everywhere. Why? Because of stuff like this. If you build your first Node.js REST API in 10 minutes, I can tell you there's not going to be any security in there. And that's okay. That's not, I mean, you're joking, you're laughing with this, but that's how we learn stuff, right? If you want to learn how to build an API on Azure, you're going to find a tutorial from a blogger somewhere from Microsoft DevRel, and you're going to follow that. And 10 minutes later, you have deployed an API on Azure, and you're like, yeah, awesome. Same thing here. There's nothing wrong with that. There's no stab at the author of this article. This is a valid article. And it teaches you to build something like this, a to-do application, of course. A to-do application, the common example, and it gives you an endpoint to delete tasks, like app.delete, that's a RESTful method, awesome, /task/task ID, and we can delete that task from the system. No security. That's okay. You're here to learn about REST, not about security. So what's the next step? The next step is like, okay, how do we add security to this API? Because we all know that we have to do it. And you're going to find another tutorial that's going to explain some kind of authentication mechanism, and you're going to add a requires auth decorator or whatever on that call. It's a middleware in Express or a decorator in Python or whatever you're doing in Spring or whatever. Awesome. Right now, you're T-Mobile. T-Mobile checked if you were authenticated when you asked your account info. It never checked who you were. So you're already moving up in the world, so that's good. What else should you be doing? Well, we're deleting stuff, so maybe we should check if the user actually has permission to delete a task. Kind of makes sense, right? So you find a way to do that, you implement that, and that's actually kind of well done as well. This is called protection against functional level authorization, or this is functional level authorization. That was in the OWASP API Security Top 10, and I don't know by heart which number, I think 5, if I'm not mistaken. Functional level authorization, basically checking if a user is allowed to perform a certain operation in the system. Very useful, very important. A lot of people get this right, actually, because it's very conceptually straightforward to analyze this, to think about this. However, this snippet of code now still has a BOLA vulnerability, a broken object level authorization issue. Why? Because we check if you can delete tasks, we never check which task you can delete. Like, hey, you can delete your task, or my task, or that guy's task, any ID you have. And if it starts at 1 and ends at 900,999, well, you can kind of guess what the other IDs are going to be. And that's okay. There's no problem in having predictable IDs. There's a problem in having no object level authorization. You have to check whether something is allowed or not. But we're not there yet. So the first takeaway here is implement functional level authorization. Very important. This permission-based approach kind of works well to enforce functional level authorization. It's intuitive, and somewhere you can map that permission to a user's role or some other properties that you like to enforce. Awesome. That's checking if somebody can perform a certain operation. Now, before we talk about object level authorization, I have a question for you. Here's 2 examples from that to-do application. Are these secure when it comes to functional level authorization? We're not talking about object level authorization yet. Is this secure, yes or no? Is this good code? Well, no, the code probably isn't very good because I paraphrased it for PowerPoint, but is this secure? Maybe, right? Who knows? is that the bottom has function level authorization checks, like has permission to delete tasks. The top example has nothing. Is that intentional? Or did you just forget it? I don't know. These are questions I ask during security assessments. I ask the team, I work with the dev teams when I do that, and I ask them, like, what are you doing there? And they're like, yeah, I think that's supposed to be like that. Like, is that publicly accessible? Like, yeah, we think so. And I have to call someone like, yeah, that's okay. Why don't we make that explicit? Because auditability is the second most important property of an authorization policy. Security is one, auditability is second, because you can't have security without being able to audit the policy. Is this according to your policy, yes or no? What if we would have written this? Allow public access, which can just be like return true. I don't care what it does. But what I care about is if you look at this code, at first glance, it's going to scream at you what it's doing. It's not like you have to look for something that's missing to induce what the intent is here. No, it says like, hey man, public access. And if this doesn't make sense, if this is like delete all users and it says allow public access, you can be like, no, let's not do that. Seriously, auditability is very important, and making things clear to understand with things like this is useful. Because now you can enforce additional rules. You can have a security scanning rule in SemGrep, for example, that says every endpoint needs to have a call to auth. Whether it's check permission, public access, we don't care, but if you write an endpoint without such an auth check, you get a bad result, you get a finding in SemGrep, and we refuse to build that code. That could be a solid policy. Auditability, you have to empower auditability. You have to force yourself and your colleagues to write code that is easy to audit, because that will be worth it in the long run. You seriously need to do that. All right. What about BOLA, broken object level authorization? Well, if you want to fix that, you'll quickly end up in a place where you really don't want to be. Because it starts looking like this, like, oh yeah, you have to check permission, delete task. And then you have managers and employees and this, and a manager can delete all tasks, but employees can only delete their own tasks. So you start to write code like, if the user is an employee, then we have to apply this additional check, and it's gonna be a freaking nightmare. Remember this auditability? Well, now your code is littered with crap like this. And then somebody says like, hey, what if we add a new role, intern, with some additional requirements? Now you have to go through your entire code base and be like, okay, and if the user is an intern, then we apply this rule and that rule, and it doesn't work. And that's why broken object level authorization is such a big issue. Making a single mistake in this authorization logic is enough to create a vulnerability. So how do we fix that? Well, take that crap out of your code. Sorry, that authorization policy out of your code. That thing doesn't belong in your code. You have to take it out to ensure that you can audit that policy again. By taking it out, we create an authorization policy. And you can call that a policy engine because it sounds very cool. It's like, or a policy decision point. It's like, whoa, awesome. It's just one place with rules for authorization. It can be as simple as if you're building a Java app, have a class, authorization. And in that class, you have functions, can delete task, which returns either true or false, and that is your policy decision point, which is a very fancy name for that. That's how you sell that to your boss. Like, yeah, boss, we need a policy decision point, which is also a policy information point. Awesome. Seriously, I'm making jokes about this, but this is really important. By centralizing this logic, you gain two things. You gain the ability to simplify your endpoint code. All of these checks go away. It now becomes authorization.can-delete task. Here's the task we want to delete. Here's the user. What do you think? And it will give you true or false, exception, no exception, whatever works for your language. Awesome. How do you audit this? Well, first of all, you check that every endpoint calls the policy, and then you look at the policy. You can literally look at the policy and be like, yeah, that makes sense. You want to change something, you change the policy. You want to see who messed up the policy? Git blame. Very easy. It's all in one location. It's seriously, it's something that you want to centralize. That's the, how do I say this delicately, the poor man's policy decision point. Just a piece of code that does all authorization checks. Awesome. If you want to be fancy, you can externalize it in a service. There's services like Open Policy Agent that allow you to define a policy in a policy language and run that as a service. So you can ask that service like, what do you think about this? What do you think about that? And these things can be very advanced, very fine-grained, down to the field level. Like this user is allowed to update that field on these types of objects. That's what you can do with things like this. Open Policy Agent is one example. OZO is actually gaining some traction as well. It's a new approach for doing authorization built by developers. It's very new, very fresh, so it's not widespread supported yet, but it's something interesting to keep an eye on if you're interested in authorization policies. All right, so encapsulate complex authorization logic. Avoid having that scattered throughout the code because it hurts auditability. It's going to make your life a nightmare to maintain that, and it's virtually impossible to secure that. Pull it out, have it centralized, look at it, have someone else look at it, make sure it makes sense. Write unit tests of your policy. That's another benefit. You can actually write tests against your actual authorization policy. Like can delete task, here's a battery of cases where it's supposed to be yes and it's supposed to be no. Awesome. All right. Let's keep going. Why not? We have time. If you want to make authorization decisions, you need to know one important thing. Who's asking to do something? Authentication is often this huge issue, like, yeah, we have to have authentication, but it plays the second violin. It's only in function of authorization. Nobody really cares about who you are, well, except trackers. But a normal application doesn't really care who you are. They care about what you're allowed to do. And to decide that, they need to know who you are. And that's what authentication really does. And user authentication is kind of this very complex topic, because the user typically authenticates once to an authentication service, and after that, we propagate the user's authenticated state. Clients authenticate often on every request. It's not uncommon for a client to be like, hey, I'm that client, do something. Hey, I'm that client, do something. With the user, well, we struggle with having users authenticate once securely, so let's keep it at once. That's fine. Users authenticate once, and then after that, we have session management, which is a dirty word in the API world. So let's not call it sessions. Let's call it, I don't know what we want to call it. Seriously, that's how we do user authentication. And that's where we get the authorization information, and with that, we can make authorization decisions. So how do you do that in APIs? What about using cookies? A J session ID. Wow. People are angry now. I can see the looks like, what? No, man. Yes, do it. It's awesome. Seriously, if you're building an API with a few hundred or a few thousand users, and you're running this yourself with your front end and your API, and you control all of this, and it's based on browser-based clients, this is really, really awesome. We've been using it for more than 20 years, and it works. And like, yeah, but we're doing cloud stuff. We're cool. We don't have application servers like Tomcat. No, we're deploying stuff on Heroku. Well, good, because Heroku has Java session handling support with a Redis cache. And I know that this is a very unpopular opinion, but web sessions work really well. They keep data on the server in a secure location. You don't have trust issues with that data. You get an identifier, you look up who the user is, and you make your authorization decision and you handle whatever you want. And some people will argue, but it's a stateful backend, but that concept is often oversimplified. I'm not saying write stateful code. I'm not saying that your code should behave differently based on what happened before. Your code can be the same. You just take some information from a server-side session object, make your decision, and you're done. And this works very well for web-based APIs. You can quote me on that. Trust me, I've done this talk quite a few times over the past few years in various formats. And after a talk, typically after a meetup or a conference talk, people come to me like, yeah, that thing you said about sessions, yeah, we switched all of that to token-based stuff, and at the end, we had no benefit in doing that. It was a major effort for zero benefits. This works really well in traditional settings, small-scale applications. I'm not saying do this if you have 15 million users, because you're going to be hurting really fast. But if you have a small system, like so many applications, this works really well, even though it's not going to get you the cool vote from your colleague developers. This works awesome. All right, what do you do if you do not want to use this? If you don't want to use sessions, but you want to use tokens, then you're very likely going to end up in the OAuth world. OAuth is kind of designed to handle cases like this. We have an authorization server where the user or the client can authenticate, or both in some cases, and we get an access token from that authorization server. And when we request access with that access token, an API is going to use that access token to make authorization decisions. That's a decoupled approach. Better, right? People are happy again. It's like, oh yes, tokens, thank you. Fun fact, you know what the bottom link uses between the browser and that authorization server? Cookies. That's how you do single sign-on, because cookies work really well in browsers, that aside. So even when you're like, yeah, we're using OAuth with tokens, no, you're also using cookies, trust me. Cookies are always there on the web. Anyway, access tokens, that's the API side of things. We don't care about the bottom link, that's whatever. APIs now get tokens. What type of tokens? This is going to be really funny, by the way. What type of tokens? Well, OAuth has two types of tokens. The first one is a reference token. You know what a reference token is?
An ID.
It's like a session ID. We just call it a reference token because now people can ignore that it's a session ID. No, seriously. A reference token is a random identifier pointing to state kept by the authorization server. So you get that token, we call it a token, it's not a JOT, it's just a random ID. We send it to the API, and the API is like, oh, thank you for that token. I'm going to ask that other service what it means. Oh, sorry. I'm going to ask that other service what it means. Almost like asking Redis cache, but let's ignore that. Seriously, that's what a reference token does. It's called token introspection, and the security people love it because it gives you very good security properties, like immediate revocability. Hey, if the user logs out, well, we revoke the reference token at the authorization server, and it becomes invalid. If the user wants to kill or terminate a session, like immediately because of a breach, you can revoke that reference token at the authorization server, and it goes away immediately. Awesome. Security people are like, yeah, reference tokens. Developers dealing with performance are like, yeah, I'm not so sure about that, because every API request typically requires an introspection call. So that's a lot of traffic that's going on. So what's the alternative? That's the sexy alternative. The alternative here is self-contained tokens, which is, well, OAuth uses very complex terms. It's a fancy way of saying it's a JOT token, JSON Web Token. And a self-contained token contains all the information in the token. It's signed. You send it to the API. The API verifies the signature. It doesn't have to call on anyone to do that. It can verify that independently, use the claims in the token to make an authorization decision. The question that often follows from explanations like this is, which one do we use? I don't know. It depends. It depends on what you're building. And that's the takeaway here. You have to understand your requirements, analyze your requirements. Because some people are just helped with a JSession ID. Seriously, if you're building a Spring Boot API, it has built-in support for sessions, you can use that. It deploys well in a simple environment for a few hundred or a few thousand users. It's going to save you at least 2 days to a week of investigation time, implementation time to come up with an alternative. It's secure, it works well, it's reliable, and it's absolutely awesome. If you were in my workshop, we have run lab sessions on an API-based application, and that application I built up myself uses server-side sessions because it's easy. And I typically don't have millions of users in my workshop because of physical room constraints. People want to come in the millions. No, that's not true. But you kind of get the idea. This is important, by the way, because if you don't understand this, if you're just following what everybody else is saying because that's what we do in modern applications for no good reason, then you're going to make things more difficult for yourself without good reason. That's essentially what I'm trying to say. But yeah, that JSON Web Token, that's probably what you're going to use, I know. That's what everybody else is using. Even with OAuth, they're like, JSON Web Tokens, that's better. And in most cases, it's not a bad idea to use them. By the way, in this image, let me skip back for a second. In this image, that token has less good security properties because you can't easily kill it if you want to, because it just lives out there. There's no control over that token when it lives. That's why we keep the lifetime short. 5 to 10 minutes is a good recommendation. That reduces the window of abuse of that token in case something goes wrong, somebody steals it, 5 minutes only. So for most applications, that would be acceptable. For some applications, even that is unacceptable. Think about money stuff. You probably don't want that token lying around for 5 minutes if it gives access to money. All right. How do you handle that Jot token securely? Well, if you were at my talk yesterday, you know that we're not going to be able to cover that in 5 minutes, so I'm not going to do that. I wrote a very in-depth blog post for 42Crunch, an API security company, last December, and the blog post is just out there, so you can go to that link and read all about Jot Security pitfalls and recommendations to avoid that. So go there and enjoy that article. Takeaway here is follow Jot Security best current practices. There's a whole spec on that. There's an RFC that contains the same information in maybe a less digestible format, but it's a very useful document nonetheless. Write a battery of tests to make sure your application handles Jot securely. If you were here yesterday, elk none, test for that. And make sure you handle Jots securely. And that brings me to the last point. What happens when poo goes wrong? I have to watch my language here. Well, too often, when something does go wrong, when some feature gets compromised, when a breach happens, the whole system comes crumbling down like a house of cards. That's not necessary. That's unfortunate and unfortunately very, very common. Compartmentalize your applications. That's the takeaway here. That's the final takeaway. Compartmentalize your APIs. Split them up. There's no reason to have an authentication part of your API sit right next to all the other application features. Pull it out as a separate service, give it a separate data store, shield it, protect it, because it's very sensitive. Goes for the other things as well. If you have an image processing service, which is very untrustworthy, it's very likely that something will go wrong there. Put it aside in a separate service, shield it on the network, don't give it access to databases, don't give it access to data, and maybe just as a precaution, kill it like every day and boot it up again to be sure. Who knows? But compartmentalization will eventually save you if something goes wrong. And that's what we want to do in the end to make things more secure. All right, now it's up to you. I've done my part. I told you what to do. That's the fun part of my job. I can just be like, that's what you got to do. Bye-bye. So now it's up to you. So audit your API authorization policy. I can guarantee you, well, probably on Monday, but I know how these things go. I can guarantee you that we will find something. Almost guaranteed. Let me know about that. It's always fun to hear that the stuff I'm doing is actually relevant. So if you find something, just send me a message or shout out on Twitter like, yeah, thank you, we found a vulnerability. Write security tests for Jots. Make sure you handle them securely. Write that open API specification. Look into these tools that use them and see how you can use them to systematically improve your security. All right. If you want to learn more, I have some online course content on API security, OAuth, OpenID Connect, React security, and so on. You can also hire me to come to your company. I'll gladly talk for 2 days about security topics, or 3 or 4 if you want to, but that's going to blow up your head. And with that, I want to thank you for being here. Enjoy the rest of the conference here, and if you have anything you want to talk about, shout at me on Twitter or LinkedIn, or grab me here at the conference. All right, thank you very much.